Hi everyone, welcome to our channel.
I'm Estella.
And I'm Aditi.
We both got 5s in AP Chem and we will hopefully help you to do the same.
In today's video, we'll be explaining stoichiometry.
Button your lab coats, tighten your goggles, and let's get to it. Yeah!
Stoic is one of the most important parts of AP Chem, so make sure to pay attention.
Stoichiometry problems can be solved through the use of dimensional analysis, which is basically how you convert between units, kind of like calculating how many inches are in a mile. The main thing in stoichiometry to understand is moles. No, not that type of mole. Moles are a unit of measurement. That basically just means a lot of a certain element, molecule, or compound. More specifically, 6.022 times 10 to the power of 23 atoms.
Yes, there are certain constants like that you need to know how to use. Don't worry though, you won't have to memorize them. You'll have all these constants on your reference sheet. Let's look at an example to start. 4Fe plus 3O2 becomes 2Fe2O3. Basically, according to Stoic, the coefficient of a reactant or product corresponds to the ratio of moles of each molecule to each other. In simpler terms, for every 4 molecules of Fe, given that there's excess oxygen, there are 2 moles of Fe2O3.
Now, let's take a look at the question. How many grams of Fe2O3 are produced when 50 grams of Fe are reacted with excess oxygen? First, we want to convert grams to moles. We do this by using the molar mass of the element found on your periodic table. This mass is in grams per mole.
Divide the given mass by the molar mass, which for iron is 55.85 grams. Now we're in moles.
Next, use the coefficients from the equation to find the moles of Fe2O3 that correspond to the moles of Fe that we just calculated. We can do this because, as stated before, the coefficients correspond to the ratio of moles in each molecule to each other. Here, the ratio is 4 moles of Fe to 2 moles of Fe2O3.
Now that we're in moles of Fe2O3, we can convert to grams. The molar mass of Fe2O3 can be found by adding the masses of the elements involved. So 2 times the molar mass of Fe, which is 55.85, and 3 times the molar mass of oxygen, which is 16. So altogether, that's 159.7 grams per mole of Fe2O3.
We'll now multiply the moles by 159.7 grams per mole in order to get the grams of Fe2O3, which is 71.87 grams. However, due to significant figures, it is rounded to 72 grams since our initial value of 50 has 2 sig figs.
Now try it on your own. How many atoms of Ag are needed to react completely with 531.8 grams of I2?
Remember to convert moles to atoms by using Avogadro's number, 6.022 times 10 to the power of 23.
Avocado? I could go for some avocado.
Here's how you would do it.
Hold up. I don't know if I get it. Can we get a recap?
No, but you can get a rewrap. No need to scream, no need to pout, just make sure all the units cancel out. Use the molar ratio, and then you'll really get into a flow.